Experimental and theoretical?
Yes.
Have we talked about this?
Yes.
Two big long words that taste great together. Anybody know the difference between experimental probability and theoretical probability? Theoretical. 5 syllables. Experimental. 5 syllables. Jeremy S. Schwartz?
Theoretical is what should mathematically happen, and experimental is what actually happens.
Okay, yeah. Theoretical is based on math, what should happen. Based on math, what should happen. Experimental is what actually does happen when you do the experiment. What happens really when you do it. Okay, for example, if you're flipping a coin, the probability of flipping a head is, theoretically, the probability
1 2.
is 1/2. Now, when you flip a coin, does that mean that you couldn't get a head 3 times in a row, or you might get a tail, whatever? That means when you flip a coin, half of the time you should get a head. But if you flip a coin 10 times, it'd be interesting to know, how many times when you flip a coin 10 times will you actually get 5 heads and 5 tails? I don't know. It may or may not happen here. But the deal is, the more times you do the experiment, the closer it will come to the more times you perform something, usually the closer it gets to theoretical. In other words, this. If you flip a coin 4 times, you know, the odds or probability of you getting, theoretically, you should get 2 heads. Okay, but that sometimes does, sometimes doesn't happen. But the more you do the experiment, in other words, if I would do 1,000 flips, I am going to probably get closer to 500 than I would if I just did it twice. The more you do something, the more these two kind of come together for whatever reason it is. And that's the reason why, okay, casinos, the lottery, bingo, why these people can make money on this is because they know the theoretical probability. For example, the lottery. The theoretical probability of you, Corinne Shellhammer, winning the lottery is somewhere in the 1 to, 100 million or something like that? Okay? So they know if it gets played 100 million times, only one person is going to win. Now, could the lottery people sell 1 ticket and that 1 ticket win? Absolutely. Okay? But they know that if you keep doing it over and over, if you keep running the lottery time and time again, eventually it's going to end up being that you're going to have to sell 100 million tickets before one of them wins. So the more you do something, the more of the theoretical probability and the experimental probability kind of mix with each other and actually get closer than they should. Let's take a look at some example problems here. And I know you're excited about that. Anybody know where we're at here? Uh-oh, that's not good. What is this, math class? No. Hold on a second, because I got some questions for you here. What are we, course 3? And we are on lesson what?
259.
59. This should come up fast because I got nothing else running down there. Watch this. 5, 4, 3, 2, 1. Not too bad. I'll give you some examples of what they're going to ask you here. Here we go. Take a look at this problem here. A softball player has 21 hits and 60 at-bats. Express the probability the player will get a hit in her next bat. Okay, this is experimental. This actually happens. So the experimental probability, when she actually does this, the probability of her getting a hit is what? How many hits did she get out of how many total? Okay, it's 21 out of 60. And feel free to reduce that. What goes into that? 3, 7 over 20. Express the probability as a decimal to 3 places. What, by the way, would that be to 3 places? 7 over 20 is what over 3 places would be 1,000. But we could do it over 100. What is it? As a decimal it is? Right, it's 0.350. But in baseball, we always go to the thousands place. So this person is batting 350, as we say. That means out of 1,000 times at bat, they should get a hit 350 times, which is a pretty good batting average if you're in the professional leagues. Softball, I don't know if that's probably not very good at softball. Is it? Depends on if it's fast pitch or slow pitch. But this is experimental. There would be no way to give theoretical probability of that because how do you gauge somebody's ability to hit a baseball or a softball? I mean, there's no exact science to that. So the only probability you have on this is really theoretical or experimental. Sorry. I'll find this one back here. Looking at another example. This one here. The commuter plane arrives on schedule 2/3 of the time on any given weekday. Heather wonders what the probability is that it will arrive on schedule on Tuesday, Wednesday, and Thursday in the same week. How could experimental probability be found? Oof, and why is this impractical? How would you be able to, what would you have to do to find the experimental probability? You would have to be there the whole day and see every time it came in on time. So it wouldn't make a lot of sense. Why is that impractical? Because it'd be your whole day, all day long there. How could the spinner on the right simulate it? Well, I don't know. I don't like this question. We're gonna move on. I don't know. Let's try this one. A salesperson distributed free samples in the mail. 50 shoppers accepted the samples and 30 did not. What's the probability that a shopper at the mall will accept the salesperson's sample? So, what would be the probability of somebody accepting it? Again, this is experimental. How many accepted it?
50.
Out of a total of how many?
80.
80. So what is the probability that the shopper at the mall will accept the salesperson's sample? 5 out of 8 people should accept the thing there. I don't know if this isn't terribly exciting.
Sorry, Mrs.
Oof, Jack was getting a little worried. Let's just do one more. A, B, C, or D? Let's go B. Quinn runs a sandwich shop. Since she added a turkey melt to the menu, 36 out of 120 customers have ordered the new sandwich. What is the probability that the next customer will order a turkey melt?
36 out of 100.
It is, but you probably should reduce that to what?
6.
6 goes into both of them. 6 over what? Cut them both in half. 3/10. 3/10 or 0.3, yeah. That's enough of that. I think it's probably time to actually do some work.